Yeah, sure. So it's like
all of chapter 4 and well, chapters 4 that we covered, so 4.1 through 4.5. I should be able to complete 5.1 and 5.2. But God help me do it. They're not hands. Okay, so trigonometric identities. The first thing that you have to know, of course, sine t, cosine t, tangent t, or x. Last time I graphed sine, cosine, tangent. You can graph the other ones using your calculator. You get to have your calculator, which is why I didn't spend as much time in that section or on that section, because the calculator will show you the graph very straight. We have the technology to use. If you want to verify trigonometric identities, there are a few basic ones that you should know. One, let's see if we can hear me now. Why?
I just remember that. I don't remember why.
You don't remember why?
Is it the unit circle? Like,
Is it?
the x, y?
So if you go back to how we define sine t, cosine t, the y coordinate is sine t. The x coordinate is cosine t. If you do x squared plus y squared, that should equal to the radius of the circle, which in our case is the unit circle, not just the radius, the square of the radius. One squared is just one. I always tell my students that is all you need to know. Everything else, don't have to memorize. Just take it from this. If I divide cosine by cosine squared t on both sides, yes, I just divided by cosine squared t on both sides. Well, I want to rewrite this. This is simply equal to sine t divided by cosine t, and you square the entire expression. Just like you have x over y, you square the entire expression, you get x squared divided by y squared. That's exactly what it is. What happens to that term? That's easy. I could do the same on the right hand side. I can write it as 1 over cosine t, and then square. Yes. Now, what is sine t divided by cosine t? Tangent. Plus 1. What is 1 over cosine t? Cosecant. Secant. Now I can apply the square, I'd end up getting tangent square t plus 1 equals secant square t. Yes, another identity. I didn't have to memorize, I just used the first one. This is what I want you to do. Instead of dividing by cosine square t, I want you to divide both sides by sine square t and tell me what you do. You follow? So I like it. Divide equation 1 by sine square t on both sides. And then simplify, you are going to get an expression. I'd like to know what that is.
Yeah,
Okay, so I want to divide both sides by sine square t. Number 1 times so sine square t. Settle down, Peter. Sine square t plus cosine square t. He's about sine square t. Divide by sine square t on the other side. Sine square t divided by sine square t. 1. Going to rewrite that as cosine t divided by sine t square. Right hand side 1 over sine t square. Good so far? Cosine t divided by sine t. Well, sine t over cosine t is tangent t. I simply flipped it. I have cosine divided by sine, so I flipped tangent. Would that be equal to tangent in there? Absolutely not. What would that equal to? Cotangent. Cotangent. So yes. Most important. So 1 plus cotangent t squared equals what is 1 over sine t? Okay, secant. I can write this as 1 over cotangent square t equals the secant square t. Good. Yes, no, okay. If you move tangent square to the other side, you have another point. I wouldn't even call it another side. Most important items, the first one, the second, and the third. There are others we will do in practice. But for now, this is good enough. Yes? Okay. Verifying identities. You should know how some identities, or not identities, some equations equal to another trigonometric equation, but they just look different. It is an example. First, not an identity, but it is an expression. I want to know is that if that segment is true or otherwise. Is it true? Now, in a problem like this, you have to start with the side that you're comfortable with the side that you're comfortable with. Left hand side or right hand side? Left. So once you simplify the left hand side and if it equals to the right hand side, then you have the answer. Or it's a big yes. Starting with the left hand side, sine theta. What is cotangent theta? We just went over it. Cosine over sine. What can we do now? What?
Signs cancel out.
The signs would go away. And I end up getting cosine theta, which is the right hand side. So is the given expression true? Yes. Is cosine squared theta plus 1 equal to cotangent squared theta? Wait. Again, you start with the side that you're most comfortable with. Which side are you most comfortable with? Left hand side or right hand side? Right, because that looks simple. So let's start with cotangent squared. And if I rewrote that, that would equal to cosine theta divided by sine theta. Yes? Square. Which will give me cosine squared theta plus sine squared theta. Correct. Is that equal to that statement? Yes or no? No. There is no way you can go here to there. So no. So the key to verifying an expression involving trigonometric identities is to pick a side that works for you. Which of the side that is easier? So here is a case. That you can try. Is cosine squared theta times 1 plus tangent squared theta equal to 1? Well, if I asked you which side should you pick, which one would you pick? The left or the right? Why the left? Huh? Go ahead. Can't hear you. Stephanie can't hear you.
Yeah, speak up.
Speak up. See? Okay, he has a cold.
Push through the pain. You got this.
You need a coach to accept it. So sure, the right hand side looks simple, right? It's just a number, but it doesn't give you any information. In other words, you have no direction as the value to go. You can do a lot of things at once, but you don't know. So you can start with the left hand side, give it a try and see if that works out. Okay, so as I went around, then if you got it on yes, the expression is actually true. There are two ways to do this. One, distribute cosine squared. Yes, you would write it as cosine squared theta times 1 plus tangent is simply sine over cosine. You could write it as sine squared theta divided by cosine squared theta. Yes? This should be cosine squared theta plus cosine squared theta times sine squared theta divided by cosine squared theta. What happens to the cosine squares? Constant. You would end up having cosine squared theta plus sine squared theta from the very first identity that I wrote. What is sine squared theta? That's a good one. Then that's actual to the right hand side. Yes. Good. Actually, sure, this is not a bad approach, but there is an easier way. Okay, enlighten us.
1 plus tangent squared is just be equal to 1 over cosine or just secant.
So I wrote 3 identities very beginning. First one, sine squared theta plus cosine squared theta equals 1. Second, 1 plus tangent squared theta equals secant squared theta. So I didn't even have to do all this. I can rewrite. One plus tangent squared theta as secant squared theta. But then secant theta is 1 over cosine theta. Square it, you would get 1 over cosine squared theta. What happens to cosine squared? Which one do you like better? Second. Comes with practice as to which approach you take. The more you practice, the better you will understand, okay, I don't even have to do that, I can simply do this. Okay. We want to verify that. Looks like a giant expression. Well, I mean, should you start on the right hand side or the left?
Yes.
You start with nothing because that's quick. So left's got more information, right? So even though this looks like a huge expression, this can be simplified easily. You have a fraction plus another fraction. What do we do? How do we combine them? Common denominator. Common denominator. What is the common denominator? Is there something in common? No, I'm not sure if your algebra professor mentioned it. If you have nothing in common, the least common denominator is simply the product of the denominators. So there's nothing in common. So that is the least common denominator. Well, I have 1 plus cosine x in the denominator. What am I missing? Very good.
Yes.
I have 1 plus cosine x. What am I missing? Look at this, look at that. What am I missing? Yes, that's what am I missing? Here.
What are you missing? Sine.
Sine, okay. So I'm going to multiply and divide by sine x. I can't simply multiply denominator, I've got to multiply and divide. On this side, I have sine x. What am I missing? 1 plus cosine x. I'm going to multiply and divide. By 1 plus cosine x. Good. With me so far. I'll give you a second to get this done. Where do we go from here? I have a common denominator. What is the purpose of finding the common denominator?
So you cannot cancel it out. Or like get rid of it. So you can add the numerator.
Either,
So you can add the numerator.
so I can combine the numerators, right? That is the purpose of finding the common denominator. So 1 plus cosine x times sine x. Numerator, I have sine squared x, agreed. Plus, what do we do with this? FOIL. Another wrong, but it's another easy way. This is an algebraic identity. What is a plus b times a minus b?
Square plus 2ab.
No, that is a minus b, a plus b squared. I want to know what is a plus b times a minus b. A squared minus b squared. You don't even have to solve it. It seems trivial now, but if you go to calculus or other level classes in the future, better to know this instead of pulling things each and every time. So a plus b times a minus b is simply a squared minus b squared. Here, a is 1, b is cosine x. So I would simply have 1 squared minus cosine squared x. Good. I can rewrite 1. Do you agree? I can rewrite 1 as sine squared x plus cosine squared x. That is the very first identity I wrote. 1 squared is just 1. I'm replacing that 1 by sine squared x plus cosine squared x. And then I've got another term minus cosine squared x. With me so far. Derive the entire thing by 1 plus cosine x times sine x.
Maybe you say dividing it because it's equal to 0, just multiply both sides with the denominator.
Well, now deriving.
You can multiply both sides by the denominators, so the denominators should improve.
So Raleigh is suggesting, well, the very first step, why don't I simply multiply both sides by the denominator? The other side is 0, and I can come to a conclusion directly. Sure, but we are trying to verify the identity. How do you know that the right hand side is actually 0? Do you see my question? That is a very logical thing to do, but I'm not doing it because it is something else. So I'm picking just the left hand side to see if I'm going to get 0. So what you are suggesting is under the assumption that the right hand side 0 holds true. What I'm saying is, I don't know, that's what I'm trying to verify. So I'm starting with the left hand side and trying to see if it would be 0. Well, doesn't look like it. Well, what's it? Numerator, I have sine squared x plus sine squared x, 2 sine squared x. Cosine squared x minus cosine squared x will get cancelled. Denominator will remain as is. Numerator, you have sine squared x. Denominator, you have sine x. You can get rid of one of the sine x. So numerator, I have 2 sine x divided by 1 plus cosine x. Now, there are certain values of x for which the expression will be true. This would equal 0. And that's not what we are trying to say. No matter what value of x you plug in, the original expression must be true, not for specific values of x. Well, in general, that expression equals 0 for every value of x that you take.
No,
Value says no, why? There are few values of x which would give us 0. For instance, Can you think of a value of x that would make the numerator 0? Easy. Well, 2 can't become 0. Yes. So sin x has to be 0. But what value of x is sin x 0? 90 degrees, 0 degrees.
Was it not that experience?
Sin 90 is sin 0 is 0. Sin 2 is 0. So if you pick specific values, you get 0, but that's not the objective. No matter what value of x I give, I must get 0 for that expression to be true. Does it? Do you have a question?
Oh, good.
Okay. So this expression is not going to equal 0 for all values of x. So is the given expression true? No. So don't do what Riley had in mind, even though it is reasonable to take that approach, that going under the assumption that you know that the right hand side is true. Our objective is not that. Our objective is to clarify that expression first. So you should start with one side and see if you get the other side. We're clear? Yes. Okay.